A circuit element is said to be linear if it satisfies two properties. First one is the principle of homogeneity, and the second one is the property of additivity. So we will understand both of these with the example of resistor, and then we can discuss if they are satisfied for inductor and capacitor as well. First we will see homogeneity. Okay, so in homogeneity what it states is that if the input is multiplied by some constant k, okay, then the output also should be multiplied by that same constant k. Okay, so if this condition is satisfied, then it is said that the homogeneity property is satisfied. Okay, so if you take the example of resistor, okay, let the current be I of t and the voltage be V of t. Okay, so for a given input current, okay, we will take the current as the input and we will take the voltage as the output. Okay, so the output V of t is related to the input as R into I of t. This is according to the Ohm's law, right? Now if you multiply the input by, there's a new input current which is k times that of the old current. Okay, now what will be the new voltage? This will be equal to the resistance into the new current I dash of t. So this will be equal to R into what is I dash of t? It is k into I of t. Okay, but what is R into I of t? R into I of t is nothing but the old voltage V of t. So you can see that the new output voltage is equal to k times the old output voltage. Okay, so you can see that the resistor will satisfy the property of homogeneity. Now what is meant by additivity? Okay, so here let us take for the same resistor R, let us say there are two inputs I1 of t and I2 of t. Okay, so what will be the output due to I1 of t? It will be R into I1 of t. Okay, so let this be V1 of t, and the output due to I2 of t will be R into I2 of t. So we will take this as V2 of t. Okay, now the sum of the outputs due to each of these currents applied separately, that is V1 of t plus V2 of t. Now this should be equal to the output due to sum of I1 and I2. This means that if the input is I1 of t plus I2 of t, then the corresponding output should be equal to V1 plus V2 of t. Okay, so we will see if that is satisfied. So what is V of t? Because of this input, it is R into I of t. Okay, so this is equal to R into I of t. You can write as I1 of t plus I2 of t. So this you will write R I1 of t plus R I2 of t. This is nothing but V1 and this is nothing but V2. So you can see that V of t is the sum of the V1 plus V2, the individual outputs due to individual inputs. Okay, so this is how we say that additivity property is satisfied. So since a resistor satisfies both homogeneity as well as additivity, it is said to be a linear circuit element. Now we will see the case of inductor, whether it satisfies both the properties, homogeneity as well as additivity. Okay, so first we will see the homogeneity property. So if you take an inductor L and the current through it is I of t and the voltage is V of t. Okay, so how will be V of t related to I of t? This will be equal to L di by dt. Okay, now we have a new current I dash of t which is equal to k times the old current. Okay, then the new voltage V dash of t will be equal to L into the differentiation of the new current. Okay, so this will be equal to L d by dt of I dash of t is nothing but k into I of t. K into I of t. Okay. Now, since k is constant, you can take it out of the differentiation. So this you will get as k into L di of t by dt. What is this expression within the brackets? This is nothing but the old voltage, right? So this will be equal to k into V of t. So you can see that for a input which is multiplied by some constant k, the output is also multiplied by that same constant k. Now let's see the additivity property. Okay, so here you have to take two inputs I1 of t. What will be the output voltage? V1 of t will be equal to L di1 of t by dt. And due to some input I2 of t, you will have the voltage L di2 by dt. Now for an input I of t, which is equal to the sum of these two currents I1 of t plus I2 of t, the corresponding voltage should be equal to the sum of V1 of t and V2 of t. Okay, so we will see whether it is satisfying. So what is V of t? This will be equal to L into di of t by dt. This will be equal to L into d by dt of I1 plus I2. Okay, so according to the property of differentiation, you can simply write L di1 by dt plus di2 by dt. Okay, so this is nothing but L di1 by dt is V1 and L di2 by dt is V2. Okay, so V of t is equal to V1 plus V2. So additivity is also satisfied. So inductor is a linear element. Similarly, if you take the case of a capacitor, okay, so this is capacitance C. Let current be I of t and voltage be V of t. So how is voltage related to current? V of t is equal to 1 by C integral I of t dt. Now let us see the property of homogeneity. For an input I dash of t, which is k times I of t, we should find out what is the voltage V dash of t. So this will be equal to 1 by C integral I dash of t dt. Okay, so this is equal to 1 by C integral I dash of t is nothing but k into I of t. So k into I of t dt. Okay, since k is constant, you can take it out of the integration. So you will get k times 1 by C integral I of t dt. Okay, so what is this expression? This is nothing but the old voltage V of t. So this will be equal to k into V of t. So for a current which is multiplied by some constant k, you're getting a voltage which is also multiplied by constant k. Next, if you consider the property of additivity. Here you take two currents I1 of t. What will be the voltage due to this current? V1 of t will be equal to 1 by C integral I1 of t dt. And for some other current I2 of t, the voltage will be 1 by C integral I2 of t dt. Now for an input I of t which is equal to the sum of the two inputs I1 of t and I2 of t, you have to find out the voltage. Okay, and this voltage should be equal to this V1 of t and V2 of t. It should be equal to the sum of V1 and V2. Okay, so let's see if that is satisfied. So V of t is equal to 1 by C integral I of t dt. So this will be equal to 1 by C integral I1 of t plus I2 of t. Entire thing is integration. Okay. So you can separate the integration. So you will get 1 by C integral I1 of t dt plus 1 by C integral I2 of t dt. Okay. So this is equal to nothing but V1 and this is nothing but V2. So you are getting that the voltage is the sum of V1 and V2. Okay. So the additivity property is also satisfied. So for a capacitor also the homogeneity and the additivity is satisfied. So capacitor is also a linear element.